This is a current carrying wire. You can see that why your teacher is giving so importance for this, especially the Ampere circuit law, because what we say electrodynamics, no, this modified form of Ampere circuit law is what will help us to study the electrodynamics, EM waves. There you can see that this Ampere circuit law we are going to modify it. What all we have, the electrodynamics, no, also like a EM wave propagation is based on this Ampere circuit law also. Gauss law for magnetism, Ampere circuit law. These things are only going to help us, you know. So it's a very, very important for total electronic and communication. So especially the electromagnetic wave propagation, no, I need this Ampere circuit law. So there we do come across all these situations. Okay, no, he's asking what's be the find the value of b bar dot dl for the line PQ. There are two segments are there, no? So we'll take segment A, B, and C. ABC is one semi-infinite, and BC is one semi-infinite. Due to AB, due to AB, what we'll get? Due to AB, due to AB, semi-infinite wire. Mu naught. Okay, fine, fine, good. Mu naught I by 8. Yeah. First, let me go for AB. No, so this angle will be how much? 90 degrees. So like that, I'll do one thing. So this is what our point P, and this is Q, no? And this is the wire into the plane. If you see from top view, this will be the condition, and this angle is what? 90 degrees, and this is the path. This is a path here. Okay, now come for this is asking the line integral of b bar dot del for this PQ. So you complete the loop. This will be much easier. You complete the loop here. Loop is not exactly of shape. Now you see that one. How much it is linking the total loop, how much mu naught I by 2, because semi-infinite wire, no? This is what semi-infinite wire, not full wire. Wire AB, it's a semi-infinite. So mu naught I by 2, of which 1/4 is linking this. So mu naught I by 8. Why there is no from due to BC? Why there is no B bar dot DL due to BC? How do it is? It is lying tangential, no? So again, you do one thing, take help of that finite wire what we discussed. So this is the path. There's a path, and this is that wire. It is lying here. BC, and this is a current I. Okay, I'm trying to somewhere you choose DL here. Okay, due to this wire, why there is no B bar dot DL? So how do this wire, shall I say it lies tangential to the plane of the loop? It will be tangential to the plane of the loop. It will be tangential to the plane of the loop. So what should be the B bar dot DL for PQ due to this wire BC? Shall I say 0? BPQ 0 due to wire BC. So then due to wire AB, it will be non-zero. How much it is? Mu naught I by 8. This is, so total how much it will be? Mu naught I by 8 only. So therefore, what is the conclusion? If a wire lies tangential to the plane of the loop, will it be B bar dot DL 0? If you say S, again you're in big trouble. In this situation, it is, don't generalize here. Any reason for that? Because you just calculate B bar at all these points. A very simple way, nothing to do. How B bar at this point due to this wire? At least you tell me how B bar will be. Into the plane, perpendicular to everywhere PQ, no? So if you draw for this particular wire, the B bar here will be perpendicular to DL bar. I think I'm trying to, this is PQ, the B bar, you have to really put effort here. So this will be, this is due to what? Due to wire BC. The B bar produced due to wire BC will be perpendicular to DL. If you want, you can check it. Okay, got it now? All right, this is over now. So many conditions are there. Ampere circuit law, you have to be very careful. So when you get a problem, do analyze all things properly, then get into the problem. Okay, now, if it is, there's a loop, because we have, just now we have made it, I'll bring a wire like this. Semi-infinite wire, let it be. What should be the value of, what should be the value of B bar dot DL for this loop? The DL is this one. Let I be the current. Will you say 0? Look at this previous problem and this problem. I'm just asking, is it 0 or non-zero? That's all. What is the, look at the value of B bar at 0.2, I think we know it, no? How much it is? Mu naught I by 4 pi r. What about field here? Field at several points, will it be 0 or non-zero? And one particular point will go to infinity, no? So what is the best way of dealing with this problem is, again, stick on to the, so let this be the perpendicular distance. Clear? And so this should be the, so this should be the alpha. This should be the beta. Alpha is 90 degrees. So what about beta? Beta will not be 90, no? It depends upon the radius and this distance. So let me call, this is D and R. It also depends on dr, no? It also depends, and at several points, again, you can see that like this, if you calculate the B bar at several points due to this long wire only, will be different. So I'm just asking, will it be greater than or less than mu naught I by 2? Of course, we can't calculate the value. Greater than mu naught I by 2, less than mu naught I by 2. The value of b bar dot dl. Shall we put less than mu naught I by 2? So what to do for this? How to conclude this? Make it a total long wire. If it were long wire, how much it should have been? If it is a long wire, how much the value would have been? Mu naught I by 2. If it were long wire, it should have been mu naught I by 2, no? Or mu naught I. If it were long wire, then at several points, again, if you take it, no, at all points, it is going to be same. This one, again, the method is same. So how to calculate B bar? You apply this, as it is a long wire, alpha beta will be 90 degrees, and the distance that will be different at different points. Is okay. So now, if it were long wire, it would have been some value. It's half of it. So formula mu naught I by 2 sine alpha plus beta. Sine alpha is 90 degrees. So 1, we got it. Beta, how I'm measuring? So if you come for beta here, if the point is here, I think now the beta will be negative, no? If it is if the point P lies, beta will be negative. So for all this semicircle, what happened to the beta will be negative. This will be positive. At this particular point, it is mu naught I by 4 pi r. At this particular point, greater than that. At this particular point, will be less than that one. So total resultant will be less than mu naught I by 2. Of course, we can't calculate. I'm just analyzing and telling it here. So not only, sir, you can, I think the basic definition, I think like current enclosed by the path. So there's no current enclosed. In fact, it is, you have to slightly come out of that definition. So there's no current flowing through the path. Still you are saying, yes, it will be. So here also, look at this. So there's no current passing through this. Current encircled by the Amperian loop. There's no current passing through it. I think their current encircled means, again, don't think that a wire should pass through it. There's not a technical way of concluding like that here. Even this also open, it is enclosing some current. So therefore, so stick on to that and analyze here. So it will be mu naught I by 2. Less than mu naught I by 2. Okay, now we'll take the, okay, this one more. Read the question. Two infinity long wires are placed